Hey everyone, Shadow Rockets here, and today I have some effed up physics for you, and today I'm actually doing Destiny, and it's going to be the jump height. So you're just seeing some footage of my testing here. I'm just going to show you the object that I thought was the same height as the object on the moon, and I'm showing you my time test to make sure that you can see that I did test the amount of time it took to follow the ground once you started jumping, and maybe I was wrong. That was just in case I was wrong with the height of the objects being the same. So without further ado, I'm going to move into the actual physics portion of this and let you see my math. So enjoy. Hey everyone, Shadow Rockets here, and here we have, I set up a little bit ahead of time, but I'm going to do a little bit of calculations with regards to the jump height on the moon, because as you saw in the footage, we just didn't have the same jump height. So, or we had the same jump height, unless I have one case where they may have adjusted for it or they may BS their way out of this. However, just to go into this a little bit, I want to explain a little bit here. I do have the mass of the Earth, the radius of the Earth, the mass of the Moon, and the radius of the Moon, the gravitational constant, and the weight formula, and how to solve for the gravitational acceleration. So this kind of gives us a feel for what I have going on. I kind of explained my way through here. I figured the ratio of the gravitational acceleration of the planet in question over the gravitational acceleration of Earth multiplied by your jump height measured on Earth should be your jump height on another planet. So it makes sense if you look into the forces and everything, you overcome that weight because your mass is always the same. So let's get right into it. I kind of want to just move along here. This isn't too difficult. I'm going to just throw in, the negative is because it's in a downward direction. It doesn't really matter. So we have our gravitational constant here. Times 10 to the negative 11th. I'm not going to write the units down for that. There's a lot of them. It's like Newton, meter squared, whooshamajig, figure it out, whatever. So essentially for Earth, we are going to end up getting really close to 9.8. We kind of just cross out our other mass. There is another mass here. It is your mass, but the mass of the Earth or the mass of the Moon greatly outweigh you or your Titan or your Hunter or your Warlock. So it doesn't really matter. So we're just going to keep going on here, power through. Let me stop getting sidetracked. Sorry about that. I know some of you, well, this might be really new for some of you. This may be something you've never seen before, so I'm going to go ahead and treat it like that and kind of take it slow. We're going to divide by the radius squared here. 6.371 times 10 to the 6th squared. And I am using metric units. I'm sorry about that. It makes it really easy to do the math and everything. I didn't want to convert to pounds. Just know that this is a ratio anyway, so it's not really going to matter that much. I can take this number here and multiply it by feet, or I can multiply it by meters or miles or millimeters. It doesn't matter because it's just a ratio. The units will cancel. So in the end, this is going to work out in my favor. This is going to equal, what, like 9... I'm going to go on a limb here. I think it actually equals 9.814 or so. Meters per second squared, throwing in those units so that you can see that they will cancel. And I'm going to do the same thing for the moon, which is 6.67 times 10 to the negative 11th. Same constant because it's a constant, go figure. 7.348 22 divided by a much smaller radius, but a radius nonetheless. Gonna go ahead and type this in on a calculator, get right back to you. I might just fast forward this. Okay, it looks like we get about 1.624, again meters per second squared. So now we're going to take the ratio. This is the G of Earth, and this is our G of our planet in question, which is our moon. Okay, so yeah, like I said, just take the ratio. We're going to take the questionable planet, which is the moon, 1.624 divided by the 9.814. And we ended up getting a ratio, let's just say G ratio equals 0.165. Now that is unitless, the units do cancel. So essentially this is saying whatever, oh, my bad. I completely fudged this up. So, whoopsie. It's going to be the opposite of this. So it's going to be essentially dividing by this. So, sorry about that. Let's just go ahead and put a little division symbol there. But flip-flop them. Sorry about that. It's going to be the jump height on Earth divided by this number will give us our jump height on the other planet. Sorry about that. Flip-flop them like I said. And so that's going to say, let's say our jump height on Earth is just 1. 1 whatever it is. So I'm taking the pen here so I can be a little smaller. Actually, you know what? Just for the sake of you being able to see, let's not do that. No need to confuse. So let's say our jump height on Earth is 1. Jump height Earth equals 1. Let's say it's 1 shadow rockets. Yes, I like that unit a lot. So our jump height on the moon would then be height moon. The moon would be 1 shadow rocket divided by 0.165, which would be a large number. About 6.06 shadow rockets. So, our wonderful made-up unit shows us that the jump height on the moon should be about 6 times higher. Sorry, I'm going to move that into the camera here. Should be about 6 times higher than our jump height on Earth. So, that being said, that was not the case in our situation in Destiny. So I'm wondering if they just didn't think about this, why our jump heights are the same on every single planet, whereas you could do this math for any of the planets we have, and you'll find out that it should never be the same. I mean, other than maybe like, well, no, none of the planets are the same, radius or mass. I mean, they can be close, but unless they make those boxes that we tested on, which also wouldn't work because I also did a time jump just to be sure, and our time was the same on both jumps, so the time would be longer on the moon than it would on the Earth because the acceleration on the moon downward is less than that of Earth, as you can see here. So essentially what I'm saying is Bungie messed up in this physics. Unless they made the boxes such that, oh, you can always, the peak of your height, let's just make everything really big on the moon so that it seems like it's the same height. That's not a thing because of the timing. I made sure to check that ahead of time. So, in essence, what we have here is a massive just abandonment of the laws of physics. Thank you for that, Bungie. And I hope you enjoy the fact that you called the moon the same size as Earth and or adjusted the radius of the moon. Anyway, friends, if you like this, if you don't mind more physics in your life, don't forget to like, favorite, comment, and subscribe on this commentary. Shadow Rockets out.